So in this video I want to focus on teach you how to go about with special angles such as 30, 45 and 60, because in your paper 1 ECZ exams you don't need a calculator, and hence they require you to know special angles to solve certain ones. Now in the first instance I want you to consider the equilateral triangle ABC, which has got side 2. What I mean, remember, an equilateral triangle is a triangle where all the sides are the same. So imagine this side it is 2, this side it is 2, and that side it is 2. If we cut it halfway there, you are going to create a 90 degrees. So this one will be divided into two equal parts. So you have a 1 and a 1. And this is what I want to put up here. You have a 1. So all the angles in an equilateral, this angle is 60, this angle is 60, and that angle is also 60 degrees. So this angle here is actually 60 degrees. When you divide it halfway, it simply means that this angle here is going to be 30 degrees and 90. This side will be 2. If you apply your Pythagoras theorem, remember I've only taken this right angle triangle. That is what we're interested in, and that is what you need to remember in your exams to draw as you do that. So if you use the Pythagorean theorem, you can actually find this side there. If you say this is x, you would have said x squared would have been equal to the longest side squared minus the other side squared. So x squared would have been 4 minus 1. It is x squared is equal to 3. To find x, you introduce the square root. So x would have been the square root of 3. So this side would actually be the square root of 3. So that is what you need to remember. And it is now this triangle that we are going to use, this right angle triangle. So I'm focusing on angles 60, 30 and 60 degrees so that I can help you with the trigonometric ratios. Remember those trigonometric ratios we talked about, which we said so, ka, tor, if you remember, or Helen, another hour of algebra, if you remember that. So you can I'll look at the angle 30 for these trigonometric ratios, and I'll also look at the angle 60 for these trigonometric ratios, because in the exam that is what they require you to do. Let me start with the trigonometric ratio. So if I say sine, and another thing that I want you to remember, if just a brief concept, if you have a right angle triangle like this, yes, we know the longest side is called the hypotenuse, but of course which one is the opposite and the adjacent will depend on the angle that you are looking at. If this is the angle where this one points, that's the opposite, and this one becomes the adjacent. But if the angle I'm looking at is this one in red where it is pointing, then this will be the opposite and this one will be the adjacent. So the opposite and the adjacent will be based on the angle that you are looking at. It is not always to say that's the opposite. No, it depends with the angle that you are focusing on. Right, so with that concept in mind, we can then try to amplify that. So I'm going to start with 30 degrees there. So sine of 30 degrees, we know sine is opposite over adjacent. So sine 30 degrees, where it is pointing, that is my opposite, and this one will be my adjacent. So sine 30, we know in this case that sine theta is equal to the opposite over the adjacent there. That's what we mean. But of course I'm not going to simplify. I hope you watched out my other videos. So sine 30 degrees will be equal to where it is pointing, that's the opposite, which will be 1 over the hypotenuse, which is equal to a 2. That is why sine 30 is equal to half, or if you want you can say a 0.5 there. All right, and if you use your calculator, don't worry, we can prove it, but you will not be using a calculator. If you say sine 30, that is going to give you a 0.5 or a half there. All right, we can also go to sine we can go to cos of 30 degrees, because I'm looking at 30 degrees. Cos 30 degrees, cos is adjacent over hypotenuse. So remember, for when I'm looking at my 30 degrees, this is the opposite, that is my adjacent, and that is of course my hypotenuse as I'm looking at the 30 degrees angle. Remember, that is what I meant. So this is going to be cos 30, it's adjacent. The adjacent is the root of 3 divided by the hypotenuse, which is equal to 2. So you can leave it in sad form the way it is. Then what about tan 30? What is that going to give me? Well, tan is simply the opposite divided by the adjacent. The opposite is the 1 over the adjacent, which is the root of 3. You can leave it in sad form like that. All right, let's also try to look at now. The angle that I'm now looking at is no longer the 30, but I'm now looking at the 60. So if I'm looking at the 60 degrees where it is pointing, that is the opposite, then this one will be the adjacent. All right, so now when you look at it this way, so it simply means that you are going to have there, we are going to have sine 60 degrees will be equal to opposite over adjacent. So what's the opposite? It is the root of 3 over the hypotenuse, which is a 2 there. All right, we can go to cos 60 degrees will be equal to the adjacent, which is a 1 over the hypotenuse, which is a 2, which will give you a 0.5. So you can see cos 60 and sine 30 give the same value. That is what we know. All right, what about tan 60 degrees? Of course, tan is opposite over adjacent, so the opposite is the root of 3 divided by the adjacent, which is 1, so it will just give you the root of 3. That is what we mean. So just work out with those ones. So that is what we mean when you talk about this one. So important things that you need to remember. You can see that sine 30 degrees is the same as cos 60 degrees. They'll both give you a 1 over 2 or a 0.5. Then if you look at cos 30 degrees, it is equal to sine 60 degrees. They'll both give you the root of 3 over 2. So that is what you need to remember when it comes to that. Now I want to show you using just a typical example of how you can go about that in my later videos. But before that, let me conclude with another special angle. This time we are going to look at what we are calling as being an isosceles. We are going to look at an isosceles, right angled, triangle. So this is an isosceles, right, angled, triangle. So for an isosceles, a right angle triangle, we can actually draw it this way. Now let's imagine that this isosceles, a right angle triangle, has got side of length 1. It has got sides of length 1, just 1 unit in this case. So that is a 90 degrees, that is a 1, that is a 1, and this is representing, if you use your Pythagoras theorem, you can get the longest side. If that is x, it would have been x squared would be equal to 1 squared plus 1 squared. So x squared would have been 1 squared is 1 plus 1, so x squared would be equal to 2. To find x, you just introduce that. So your x would be simply the square root of 2. So this guy, you are going to have the square root of 2. In most cases in your exam, this angle here is a 45 and that angle is also a 45. So it doesn't matter which one you actually use. So you can look at, sine 45. You can use whichever you want. Sine 45 degrees. Let me say I'm using this one. This is the opposite adjacent hypotenuse. So sine 45 will be equal to, remember, so when you remember your SOHCAHTOA, it's opposite over hypotenuse. So my opposite is 1 over the square root of 2. Then what about cos 45 degrees? Well, it is adjacent, which is 1 over the hypotenuse, which is the root of 2. And hopefully we are together. What about tan 45? This is equal to opposite, which is 1 over, adjacent, which is 1. It will give you 1. If you use your calculator, you'll be able to come up with this one. Well, in the next video, I'm going to show you how you can now apply this. But what is going to be common in your exam is angle 30 and 60, and hence that is what you need to remember. Sine 30 cos 30, remember, gives you the same thing, which is 1 over 2. That's the common one that you are going to find. In my next video, I'm going to show you how you apply special angles to answer questions. Thank you so much for watching.